Let's explore what would happen if you combined all the elements. This is a thought experiment, of course, since it's practically impossible. But let's imagine we could somehow force all 118 elements of the periodic table together into one giant mass. 1. Initial reaction. The immediate result would be a cataclysmic explosion. Highly reactive elements like the alkali metals, group 1, and halogens, group 17, would violently react with each other and pretty much anything else. Things like francium and fluorine would be particularly explosive. The sheer amount of energy released from these reactions would be astronomical. We'd see immense heat and light generated, potentially creating a short-lived, incredibly bright, and incredibly hot star. 2. Nuclear processes. Many of the elements are radioactive. The sheer density and proximity of these radioactive isotopes would likely trigger further nuclear reactions, such as fission and possibly even fusion, depending on the conditions. This could lead to the formation of even heavier and potentially even more unstable elements. This could also release more energy than even the initial chemical reactions, further increasing the size of the explosion. 3. Gravitational collapse. If by some miracle the initial explosion didn't completely obliterate everything, the immense mass of the combined elements would exert a powerful gravitational force. This would begin pulling the remaining matter inward. Whether this leads to a stable object like a neutron star or a black hole depends on the final mass after the initial energy release. But it's highly likely some form of extremely dense object would result. 4. Element stability. Many elements are inherently unstable. In their natural state, they break down into simpler elements through radioactive decay, with the rate of decay depending on half-life. Putting them all together would not necessarily stabilize them. In fact, the sheer proximity to other elements could destabilize some elements, and perhaps even cause the formation of new ones through various nuclear processes, including nuclear fusion. 5. The final result. The ultimate outcome is almost impossible to predict with certainty. The most likely scenarios involve either a complete dispersal of matter across a large area after the initial catastrophic explosion, or the formation of an incredibly dense, possibly unstable object with extreme gravitational pull. The chances of anything resembling a stable compound or a predictable substance are essentially zero. The scale of energy release and the complex nuclear processes involved make definitive conclusions extremely difficult. It's likely there would be a highly energetic and short-lived event.